Hey everyone, it's Christian, the P4 working with Dr. Matulowicz for my last rotation. If you have any questions about the course or the content, feel free to let me know. Otherwise, here's the video on examples about suppository calculations. So just a few important concepts before we start with the examples. Concept number one, when you're calculating the amount of base you need, as the lab manual says, you only need to account for base displacement if the mass of the ingredient, especially silica, is greater than or equal to 25 milligrams per suppository. Key word here is per suppository, not the total mass, but per suppository, because it's no longer small enough to be negligible. So basically, pay attention to silica. If you ever see silica, make sure you pay attention. If it's 25 milligrams or greater than 25 milligrams, then you want to account for it in your subtraction in figuring out your total mass of base needed. I'll go over some examples later in the video. Concept number two, you're always making extra suppositories to account for loss, like a suppository breaking, making a suppository incorrectly, or other losses. Number three, always watch out for your units. You always want to make sure you're subtracting or multiplying or dividing the same units. Mostly subtracting. So you can't subtract milligrams from grams. You can't subtract grams from milligrams. Make sure you're subtracting grams for grams, milligrams for milligrams. That's going to be important in the examples. And concept number four, concept of density factor. So before I go into that, if you haven't made suppositories before and want to see what density factor actually is, so I'll walk through a visual or pictorial representation of suppository making. So if you read the manual, the lab manual, you saw that you have a mold or a cavity that holds suppository when you're making it. So here's your mold, and here's the cavity that'll hold whatever substance you're going to mold into a suppository. Call it the mold. And then we're going to add two substances. Number one is the base. And then number two, so the base will be blue. And then if you're colorblind, I'm so sorry. But hopefully you can see the different hues. The yellow will be the active ingredient, or AI is the active ingredient, which is yellow. So let's say you got a beaker. And then you're gonna fill with your base, and you're gonna pour it into your mold cavity to fill up the mold cavity. So now this mold has turned into a base only mold. So now, let's see, you're going to actually make the medicated suppository. So now you're going to add the AI, or the active ingredient. So you got your beaker here, filled with your AI. And then you're going to pour this AI into your mold cavity. So as you know, the first law, one of the big laws of physics, is two things can't occupy the same space. So once you fill this AI into the mold cavity, you're going to displace or remove a particular amount of base, the particular weight of base that was taken up by the AI. How much is that? Well, it depends on the density. So the density is defined as over here, density factor, which is grams of drug in each suppository divided by grams of base displaced. So how much of the base that was taken out when you added the AI can be figured out by the density factor, which is the grams of drug in suppository. Specify each suppository divided by the grams of base displaced. So if you know the density factor, which you can find in tables or you can figure out by yourself, which we'll do in a few examples, and you know the grams of each drug in each suppository by the script, then you can figure out the grams of base displaced. Another concept I want to go over is a medicated suppository, since I'll use that term later on. So as I said here, as I was talking about in this picture, when you added the AI to your base in the cavity or the mold cavity, it turned from a base only cavity into a medicated cavity. So here's your base, which is blue, and here's the AI that was added into the mold, the cavity. And then here's the base displaced by the AI once the AI was added to the mold containing the base. So now this whole cavity can be considered a medicated cavity, where if you see from the picture, or medicated suppository, same thing. Sorry. As you see the picture, it's made up of the weight of the base remaining plus the weight of the AI. So I just got that from the picture represented here. And then now you can also, another important concept is how much base, or how much of the grams, how much is the weight that was displaced. Well, if you don't know the density factor, as here, then you can do another sort of math where you can figure out if you know the weight of the medicated suppository and you know the weight of the AI and the weight of the base remaining, then you can figure this out, which is the weight of the base displaced, because you have the base only, which is derived from this picture. So the base only is composed of weight of the base remaining plus the weight of the base displaced. And if you know the weight of the base only and you know the weight of the remaining base, then you can figure out how much weight is displaced. I'll go over this picture separately in each example, especially the last two examples, since it looks a little complicated, but hopefully this will give you a little overview of what we'll go over in this video. So speaking of examples, so I have two examples of each concept where the density factor is given and the density factor is not given. So the first problem, so basically all four problems, all suppository example calculations have the same 6 steps. You're gonna determine the total amount of suppositories needed, number 1. Number 2, you'll determine the amount of active ingredient needed. Number 3, you'll determine the amount of silica needed. Number 4, you'll determine the amount of base only, or basically theoretical amount of base according to the mold capacity. Number 5, you'll calculate the amount of base displaced by the AI. And number 6, you'll calculate the amount of base actually needed. So to put the words into actual math, we have example calculation number 1. You're making hydrocortisone 700 milligrams suppositories, QS with a suitable base. You're going to make 4 suppositories, and the directions for use are 1 suppository vaginally at bedtime. So the problem is, for each 700 milligrams hydrocortisone suppository, fatty base and 0.021 grams of silica gel will be used. We're going to calculate the amount of hydrocortisone, silica gel, and fatty base needed for 5 suppositories. We're making 1 extra from the 4. And we're going to use a fusion method of compounding using a flexible rubber mold with a 1.9 gram per capacity. The density factor is given for hydrocortisone fatty base at 1.5. So as it says, step 1, we're going to determine the total amount of suppositories needed, accounting for the extra suppositories. So we know from here we need 5 suppositories. So number 1 is 5. Step 1 is 5 suppositories. Number 2, we're going to determine the amount of active ingredient, which is hydrocortisone, needed to prepare this prescription. So we know we have hydrocortisone 700 milligrams in each suppository. so 700 per suppository, and we have 5 suppositories. Multiplying it so the units cancel out, suppositories, the denominator cancels out with suppositories in the numerator. That gives you 3,500 milligrams of hydrocortisone, which when you convert to grams, it's 3.5 grams. 3.5 grams of hydrocortisone. Step 3, we're going to determine the amount of silica needed to prepare the prescription. So let's see. So we know that in each suppository, 0.021 grams of silica will be used. So 0.021 grams of silica per suppository times 5 suppositories to cancel out the units. Within suppositories in the numerator and the denominator, you get 0.105 grams of silica. Step 4, we're going to determine the total amount of base according to the mold capacity. So we know each mold holds 1.9 grams per cavity, and then let's say we're gonna fill each mold with only base. So that's a theoretical total amount of base if you fill each mold with just base. So according to the mold capacity, each mold can hold 1.9 grams per mold. And we're using 5 molds because we're making 5 suppository. Molds cancels out with molds. So 1.9 times 5 is 9.5 grams of base. Theoretically, that's the theoretical total. You can see why I say that later. I'll get to it. So step 5, given the density factor, calculate the amount of base displaced by the AI. So to illustrate this in picture form, we have a mold filled with fatty base, and then now, let's see. It's gonna be made of 1.9 grams of base. So now let's see, if we add the AI, which will be white, if we add the AI, it'll force this particular amount of base out of the cavity so that the AI can fill. And how do we know how much this is? What's the weight of that? Well, we know from the density factor, because density factor is grams of drug per suppository divided by grams of base displaced. So this step we're gonna use it, given the DF, density factor, calculate the amount of base displaced by the AI. So we know that the density factor is 1.5. So 1.5 equals how many amount of grams in drug, amount of drug in each suppository is 700 milligrams divided by, we'll call grams of base displaced X. We can convert that to grams, so 0.7 grams divided by X. So solving for X, so 1.5 equals 0.7 grams over X. Solving for X gives you, let's see, 0.467 grams displaced base per suppository. We know we're making 5 suppositories, so 0.467 grams base displaced per suppository. Remember, the original density factor equation is listed as grams of drug per suppository, so you have to use the final answer would be displaced base per suppository, so it'll be written as this: 0.467 grams base displaced per suppository. Then we're making 5 suppositories, so suppositories cancels out, so 0.467 grams base displaced times 5 suppositories would give you a total of 2.33 grams total base displaced. So that was step 5. So step 6, we're going to calculate the total amount of base actually needed to fill the molds. So as I said earlier, as I drew a picture earlier, so let's see. Here we have a picture. When we started, we had, here's your mold, then here's your base only. Then now we added, so now this is your total base. And now we're going to add the AI. And then that'll displace this part of the base by the AI. So now you have a medicated suppository. So we know that there is a total amount of 2.33 grams of base displaced. So we know this is 2.33 grams of base displaced. We know the total base, which is this. Let's do a different color, sorry. We'll do this plus this. That remaining base should give you the total amount of base needed, which is from step 4, which is 9.5 grams of base theoretically total. So that's the total amount of base needed. We know that's all 9.5 grams. So how much is this part? So we can do that because we know either this formula or just concept. So the total, as I gave you the concept, the theoretical total amount of base is the actual grams of base plus grams of base displaced by the AI plus maybe silica. So I'll write that down here. We know theoretical total amount of base equals actual grams of base plus grams displaced by the AI plus silica question mark. I put silica question mark because, as you remember, we only account for silica in the subtraction if it's at least, so greater than or equal to 25 milligrams. So as you can, per suppository. So as you can see listed here, silica is 0.021 grams of suppository. So that's 25 milligrams. 25 milligrams. So, well, oops, sorry, that's not 25. That's 21 milligrams, which is less than 25 milligrams. So you don't need to account for it in the math. So in the calculation of this, you can cross the silica out. So now the theoretical total amount of base makes sense in this picture. So theoretical total amount of base is 9.5 grams equals, don't know my actual amount of base, which is right here. What's that? Don't know. Plus the grams of base displaced by AI. So this is this right here. So that's the grams of base displaced by AI. So hopefully this picture can show you how the math comes out. If not, you can just memorize the formulas. Or you can just see the other examples I have. Let's see. So the grams of base displaced by AI is 2.33 grams. So solving for x, so 9.5 minus 2.33 gives you 7.17 grams of fatty base. So now for this prescription, you need 7.17 grams of fatty base, you need 0.105 grams of silica, and you need 3.5 grams of hydrocortisone. So that's one example. Another example is here. A compounding pharmacist needs to prepare a prescription for 18 suppositories, each containing 250 milligrams of levetiracetam, Keppra, it's an anticonvulsant or anti-seizure med, and 35 milligrams of silica gel. The pharmacist decided to use PEG as the base, so the density factor of Keppra in PEG is 0.38. Each mold can hold 2.5 grams per cavity. We're going to calculate the amount of ingredient each ingredient needs to compound the prescription with 2 extra suppositories. So step 1, we're going to figure out how many total suppositories we need. So step 1, we know prescription calls for 18 suppositories. We're making 2 extra suppositories. So that gives, we're going to need total 20 suppositories. Step 2, we're going to determine the amount of active ingredient needed to prepare the prescription. So the active ingredient is Keppra, levetiracetam. Each suppository, I'll use the brand name since it's faster to spell. Keppra, each suppository, so 250 milligrams per suppository of Keppra. We're making 20 suppositories. Suppositories cancels out in the numerator and denominator to give you 5,000 milligrams Keppra, or 5.5 grams, just 5 grams. Number 3, we're going to calculate the total amount of silica needed to prepare this prescription. So we know silica gel in each suppository is 35 milligrams. So 35 milligrams per suppository of silica. We're making 20 suppositories. Suppositories cancel out in the numerator and the denominator to give you 700 milligrams silica, or 0.7 grams. Step 4, we're going to determine the total amount of base according to the mold capacity. So we know each mold can hold 2.5 grams per cavity. So theoretically, you could hold a total of base equivalent to, so 2.5 grams per mold. We're making 20 molds for 20 suppository. Mold cancels out, and that'll give you 50 grams theoretical total base. Step 5, we're going to calculate, given the density factor, we're going to calculate the total amount of base displaced through AI. So you know the density factor of Keppra and PEG is 0.38. So pictorially, you have your mold, your PEG is your base in blue. So each mold holds about 2.5 grams per mold. Let's say you're going to add that medication, so Keppra. Here's your beaker of Keppra. You're going to add the Keppra, and once you add it, it's going to displace this much amount out of the cavity once the Keppra fills this. So how much is this? Well, it depends what the weight, density and the weight of Keppra is. So we know the density is given by grams of drug per suppository divided by the weight of the base displaced. We know the density factor is 0.38. We know the grams of drug per suppository is 250 milligrams per suppository. And we're trying to figure the grams of base displaced. Call that X. So X is 250 divided by 38 is, well, let's convert it to grams first. So 0.38 equals 0.25 grams of Keppra per suppository divided by X. X equals 0.6579 grams per suppository. We're making 20 suppositories. So suppositories cancels out. X ultimately gives you 1.16 grams total base displaced. So now we found the total base displaced. So we're going to move on to step 6. We're going to calculate the total amount of base actually needed to fill the molds. So we remember the formula earlier. Theoretical grams of base equals actual grams of base plus base displaced by AI plus grams of silica. So pictorially, we had over here your mold, filling it with PEG as the base. So that's your base. And then once we added the AI, here's your beaker. It's gonna displace that amount of base based on, is base even a word anymore? Based on the density. So we know the total, so we know this is the base displaced. We knew the total amount of base, which is this one plus this one. We know that, but we don't know this, what's remaining in the cavity. We also have to account for silica because silica is actually now big enough to take up space in this mold. So this is silica taking its happy space in this mold. It's actually big enough because we know that since there's 35 milligrams of silica gel per mold, we know that 35 milligrams is greater than 25 milligrams. So now we have to account for it in the mold. It's big enough to take up space in the mold. So we know the amount of grams of base displaced, which we figured out was 13.16 grams. We know the total base. Which from step 4, because step 4 we determine the total theoretical amount of base based on the mold capacity. So step 4, the total amount of base was 50 grams. And we know this amount of silica was 0.7 grams. So putting it all together, we know that, theoretical total amount of base equals actual grams of base plus your grams displaced, actual or remaining. So actual is also remaining. That's terrible handwriting. Actual remaining grams of base plus grams displaced by the AI, plus now we're accounting for silica gel, grams of silica gel. Since it's greater, the amount per suppository is greater than 25 milligrams. So we know the theoretical total amount of base is 50 grams. The remaining amount of base we're trying to figure out. The grams of base displaced by the AI is 13.16 grams. Plus the amount of silica gel, since it's big enough to be accounted for, since it's greater than 25 milligrams per suppository, is 0.7 grams. Notice how everything's in grams here, because as I said in one of the important concepts in the beginning of the video, you have to subtract like units. So make sure everything's in grams or in milligrams, as long as they're the same units. So let's see, 50 minus 13.16 minus 0.7 would give you 36.14 grams of base needed. Let's see. So we know we need 36.14 grams of base. We know we needed 0.7 grams of silica. And we know we needed 5 grams of Kepra. So that answered the question. So now what do we do if we're not given the density factor? So here's a problem. The next two problems, we're not given a density factor. So this first problem, we're making morphine 100 milligram suppositories, QS with VCU base. We're going to make 90 suppositories, and the directions is 1 rectally every 8 hours as needed for pain. So here we have a morphine suppository prescription that our pharmacy needs to compound. When the suppositories are made with VCU base only, the average weight of each suppository is 1.3 grams. Once the 0.1 grams of morphine is added to the appropriate amount of VCU base, the average weight of the medicated suppository is 1.1 grams. So we're using VCU base as our base. Each suppository is going to contain 25 milligrams of silica powder. Each suppository mold also holds 1.2 grams. So we're going to account for a 10% extra loss during compounding. And then finally, we're going to calculate the amount of each component, morphine, silica, and VCU base needed to prepare the script. So as always, step 1, we need to figure out how many total suppositories we're making. So we know we're making script says, oh, that's white. When the script says 90, we're making 90 suppositories, but we're also counting for a 10% extra loss. So just like making powder packets, we're going to do 10% more. So 10% of 90 gives you 9. So 90 plus 9 gives you, we're making 99 suppositories. Step 2, we're going to determine the total amount of active ingredient needed to prepare the script. So each suppository contains morphine 100 milligrams. So 100 milligrams per suppository times 100, nope, sorry, 99 suppositories. Suppositories cancels out, leaving you with 900 milligrams of morphine, or 9.9 grams of morphine. Step 3, we're going to determine the amount of silica needed to prepare the prescription. So we know each suppository contains 25 milligrams of silica. So 25 milligrams of silica suppository. We're making 99. Suppositories cancels out. 25 times 99 gives you 475 milligrams, or 2.475 grams of silica. Step 4, we're going to determine the theoretical total amount of base based on mold capacity. So assuming the mold's only going to hold just base, you know, each suppository mold holds 1.2 grams. So 1.2 grams per mold. We're going to need 99 molds. Molds cancels out. 99 times 1.2 gives you 118.8 grams theoretical total base, assuming the molds are just gonna have base. So step 5, given the density factor, we're gonna calculate the amount of base displaced by the AI. However, here we need to calculate the density factor since it's unknown. So here we need to calculate the density factor since it's unknown. So as I said earlier, let's see. We know density factor is grams of AI per suppository divided by grams of base displaced. So how do we figure out the amount of grams of base displaced? So if we know from when I drew the picture earlier, we know here's your mold, we're going to fill it with base. And then we're going to fill it with the AI. So here's your AI, we're going to fill it, displace this equal amount of base out, and the amount is based on the density and the weight of the AI. So we know, so this is your new, as I said in the beginning of the video, this right here is your medicated suppository. We know that weight is the weight of, average weight of the medicated suppository is 1.1 grams. So you know that's 1.1 grams. Oops. We know that each suppository has an active ingredient of 100 milligrams of morphine. Which is equivalent to 0.1 grams of morphine. So now we can figure out this, which is base remaining. You put that in a different color. Base remaining. So we know the medicated suppository is equal to the medicine plus base. Hence, medicated suppository. So we know the medicated suppository is 1.1 grams. We know the medicine is 0.1 grams. So the base remaining, base that remains, is X. Solving for X gives you 1 gram of base remaining. So now we need to figure out how much. Now we know that this is 1 gram. How much is this right here, which is the base displaced? Well, if you remember from our earlier concepts, we figured it out from the total base. So total base equals or the base only. Total base or base only equals base remaining plus base displaced. So we know the base only suppository, VC base only, average weight of each suppository is 1.3 grams. Let me move this for you. Oh, not that. Oh, whatever. Sorry. So we know total base is 1.3 grams equals base remaining is 1 gram plus base displaced is X. So base remaining is 1 gram, base displaced is X. Solving for X gives you 0.3 grams base displaced. Now we know that's 0.3 grams right there. And pictorially, one more time for the fans, here is your base. And then that's your base only. We know that was 1.3 grams. We know, well, after we add the AI, it's going to displace this much, equivalent to how much the density and how much AI was there. So we know the total base is equivalent to the base displaced and the base plus the base remaining right here. So that's the equivalent to the amount of base only. So now we have information to the displacement factor. So dF equals the grams of AI per suppository, which is 0.1 grams per suppository. And I'll be lazy here, multiply by 99 suppositories. Suppositories cancel out, divided by the grams of base displaced, which is 0.3 grams. And density factor, oh sorry, don't multiply by 99 there, not yet. So we'll just figure out the density factor, not anything yet. So let's see. So density factor is 0.1 divided by 0.3, which is 0.33. So now we can calculate the amount of base that we can figure out. Step 5. Given the density factor, calculate the amount of base displaced. Oops, sorry. So, given the density factor, we're going to calculate the amount of base displaced by the AI. The total amount of base displaced. So we know the density factor is 0.33. We know the this is actually given by grams of AI per suppository divided by grams of base displaced. So 0.1 grams per suppository times 99 suppositories. Oh, sorry. Suppositories cancels out. Divided by X, which is grams of base displaced. So 0.1 times 99 divided by 0.33 gives you 30. 30 grams of base displaced. So now step 6, we're going to calculate the total amount of base actually needed. So let's see. You know, the formula is theoretical grams of base total equals grams of base remaining plus grams of displaced. And then do we need to account for silica? Let's see. The amount of silica per mold is 25 milligrams of silica. So yes, we do need to account for it because it's greater than or greater than or equal to, namely equal to 25 milligrams plus silica. So theoretical total amount of base is given in step 4, where we calculate the theoretical total amount of base based on mold capacity, which is 118.8 grams. 118.8 grams equals base remaining is 1 gram of base remaining plus grams of base displaced is 30 grams of base displaced plus total amount of silica, figure out in step 3, which is 2.475 grams of silica. Notice how everything's in grams. Oh wait, sorry. So we don't know the base remaining. Sorry. So it's gonna be X. Sorry. That's 2.47 grams of silica. And solving for X gives you 118.8 minus 30 minus 2.475 gives you 86.3 grams of base needed. So we need that. We needed 2.475 grams of silica, and we needed 9.9 grams of morphine. Now for the last problem, I'll go through it real quick. No more pictures, since I hopefully get the pictures by now. If not, feel free to ask me or someone else an explanation. A prescription calls for 8 suppositories, each containing 280 milligrams of acetaminophen and 23 milligrams of silica gel. Pharmacist is using fatty base, and molds calibrated for 2 grams suppositories and fatty base, meaning that each mold can hold 2 grams, and the weight of each suppository with only fatty base is 2 grams. Once the 280 milligrams of acetaminophen is added to the appropriate amount of fatty base, the average weight of each medicated suppository is 1.8 grams. We're going to calculate the amount of each ingredient needed with 2 extra suppositories. So step 1, calculate the total amount of suppositories needed. So we know we need 8 suppositories with 2 extra, so we need a total of 10 suppositories. Number 2, we'll calculate the amount of grams of active ingredient needed. So we need 280 milligrams of acetaminophen, and we're making 8 suppositories. So that's 280 milligrams of APPE per suppository times 10 suppositories gives us, suppositories cancels out, gives us 2,800 milligrams of acetaminophen or which is 2.8 grams. Number 3, we'll calculate the total amount of silica needed. So we know this script, we're going to use 23 milligrams of silica gel per suppository. 23 milligrams per suppository. We're making 10 suppositories. That gives us 230 milligrams of silica. Step 4. Well, you need to calculate the total amount of base according to mold capacity. So we know the mold capacity, each mold can hold 2 grams. So 2 grams per mold. We're using 10 molds. Molds cancels out to give us 20 grams. Theoretical total base. Number 5, given the density factor, we'll calculate the amount of base displaced via AI. But here, we don't know the DF, density factor, so we need to calculate it. Let's see. So, whatever, I'll just draw the picture. Here's your mold. Here's your base. Once you add the AI, you're displacing this amount of base to fill it with AI. So this is your medicated suppository. We know that weight is weight of the medicated suppository is 1.8 grams. So we know that's 1.8 grams. We know the mass of the AI right here is in each suppository is 0.28 milligrams or 0.28 grams. So now we can solve for this, which is the base remaining. So now we can do 1.8 grams equals 0.28 grams plus base remaining. We'll call that x. So solving for x, so 1.8 minus 0.28 gives us 1.52 grams of base remaining. So now our next picture, here's our mold again, filling it with base. Oops, wrong color for base. Drop that base. Here's your base. So as you're filling it with AI, let's get seal. We're gonna displace this amount outside with AI. So you know the base displaced. Now we know the base remaining is 1.52 grams. We know the total base, which is this plus that, should be, or the weight of the base only, should be, only fatty base is 2 grams. So we know 2 grams is equivalent to base displaced plus the 1.52 grams. So 2 minus 1.52 gives you 0.48 grams base displaced. So now we can figure out the density factor because it's given as grams of drug per suppository divided by grams base displaced. We know grams of base per suppository is 0.280 grams of APPE, acetaminophen, divided by grams of base displaced is 0.48 grams. So density factor is 0.28 divided by 0.48. That gives you 0.58. Density factor is 0.58. So now we're going to figure out how much grams of base displaced overall. So step 5 says, given the density factor, calculate the amount of base displaced by the AI. So, let's see, 0.58 equals grams of drug per. So we have 0.280 grams APPE per suppository. We're making 10 suppositories. Suppositories cancels out, divided by grams, X is grams of base displaced. So total amount of grams of base displaced is 4.83 grams total base displaced. So now we can calculate the base actually needed to fill the molds. So silica gel, how much silica gel are we counting for silica gel in this calculation? Let's see, so each suppository contains 23 milligrams of silica gel. So 23 is less than 25 per mold or per suppository, so you don't need to account for it. So now your theoretical total grams base is just grams of base remaining plus grams displaced. We know theoretical total amount of base from step 4. Since here we have to calculate the theoretical total amount of base based on mold capacity, assuming we're just filling the molds with base. Step 4 is 20 grams. 20 grams equals how much bases remaining? X plus grams of base displaced is 4.83 grams. 20 minus 4.83. Notice it's all in grams, not milligrams. Not one is in grams, one's in milligrams. They're all in grams. That should give you 15.17 grams of base needed. That means we needed also 2.8 grams of acetaminophen and 230 milligrams of silica. So hopefully that cleared up all calculations about suppositories. If you have any questions, feel free to let me know or the course creators, the coordinators know. Otherwise, let me just reiterate the most important concepts you should know. Make sure you always account for silica, or make sure you always see if you need to account for silica. If it's greater than or equal to 25, you definitely need to account for silica. Number 2, you're always making extra suppositories. Number 3, always watch your units. Don't mix grams and milligrams in the same equation or the same problem or the same calculation. And number 4, understand how density factor works. It's grams of drug in each suppository divided by grams of base displaced. And I hope that was useful. Again, feel free to let us know if you have any questions. And good luck with studying for exams.